Okay, so with the coastal and continental temperature ranges lab, so the graph is the first part of it, and so your discussion questions are going to be based on the graph. Make sure you do your vocabulary. Remember, insolation is incoming solar radiation. It's how we receive electromagnetic energy from the sun. So make sure you're using that definition. Insolation with a U in it is like the pink stuff that you put in your attic and that keeps your house warm. Insolation has the word sol in it, right? Sol means sun. So that has to do with incoming solar radiation. It's just basically sunlight. If you weren't here yesterday, make sure you go to weatherbase.com to get your data for your data chart. The video's on YouTube on how to do the graph. So if you're stuck on the graphing part of it, you're welcome to stay after the session and I can help you with that. Or if you go onto YouTube, you'll see the directions on how to do the graph by hand, like using any piece of paper, or by using Excel. If you have access to that computer program, you can do it either way. All right, so let's get to the discussion question. If you're doing this on a piece of loose leaf, like on the side, if you can't print out a copy of the lab, that's totally fine. You don't have to write the question over again. You can just restate the question in your answer like we do with the other labs. So, question number 1. By looking at your graph, how could you tell that Alice Springs is in the southern hemisphere and New York, Bismarck, Los Angeles, and Phoenix are in the northern hemisphere? Now, do not say, please do not say that it's because for Alice Springs it's hotter in the summertime, because that's too vague, because it's always hotter in the summertime, and the summertime is going to vary depending on which hemisphere you're in. So the answer for that question is, you can tell that Alice Springs is in the southern hemisphere because the warmer months are during our winter, right? So their seasons are opposite of us in the southern hemisphere. So the cutoff is the equator. So right now we're moving towards summer, and the southern hemisphere is heading towards their winter, right? So you can tell that Alice Springs is in the southern hemisphere because the warmest months are during December, January, and February. So the seasons are opposite of ours. Okay, so that's for number 1. For number 2, do you think the unknown city is in the northern or southern hemisphere? So again, we're looking at when it's the warmest. And based on the numbers there, I see the warmest numbers are 85, 86, 85 in June, July, August. Well, that's our warmest months too. So the unknown location is most likely in the northern hemisphere because the warmest months are in June, July, and August. You don't want to say that it's hotter in the summertime because, again, that's true in either hemisphere. It just depends on which hemisphere when that timing is. So the unknown location is most likely in the northern hemisphere because the warmest months are in June, July, and August, and that's when the northern hemisphere is tilting towards the sun. Opposite of that, 6 months later, the southern hemisphere, my elbow, would be pointing towards the sun. It's hard for me to do it illustrated this way, but the North Pole is pointing away, so that'd be our winter time. Right? Remember that distance from the sun has no effect on seasons. It's all about our tilt and how much direct sunlight we're receiving. All right, for number 3, you'll need to do this one on your own, but I'll tell you how you do it. So to find the range, you take the highest temperature out of the 12 months and you subtract it from the lowest temperature out of the 12 months. So for example, I have the data for unknown right now. So let's go back to that. So unknown, my highest temperature was 86 and my lowest temperature is 79. So the temperature range for the unknown location would be 7 degrees Fahrenheit, 7 degrees Fahrenheit, right? So you just take the warmest temperature out of the 12 months and you subtract the coldest temperature out of the 12 months, and that gives you the range. Okay. So that's what you do for number 3. So you'll have to do that on your own. All right. For number 4, this was something that, like, when we did the lab in class, I would have the students like plot the locations on a map and then talk about where it was located. But it's hard to do that remotely, so I just gave you the information. So New York is on the Atlantic Ocean, so it's considered coastal. It's on or near a large body of water. Bismarck, North Dakota is what's known as landlocked. That means it's surrounded by land. It's not on a large body of water like an ocean or a large lake. Bismarck, the city itself, is surrounded by land. Los Angeles is coastal. It's located on the Pacific Ocean. And then Phoenix, Arizona is landlocked, meaning again that it's surrounded by land on all sides. So by looking at your graph and answers to questions 3 and 4. What do you notice about the temperature ranges for continental cities versus coastal cities? The answer for that is that the temperature ranges for continental cities are going to be greater than the temperature ranges for coastal cities. So what you'll notice is when you subtract the highest temperature out of the 12 months from the lowest temperature out of the 12 months, the biggest number will be for your continental cities like Bismarck and Phoenix. So continental cities will have a greater temperature range than coastal cities. For number 6, the reason for that is that large bodies of water moderate the climate. And what that means is that it'll make the summers cooler and the winters warmer, so it evens out the temperatures. So explain what caused the city with the largest temperature range to be like that. Okay, so on the other hand, the one that has the largest temperature range, I'm not sure, I forgot which one that is off the top of my head, but you'll get that out of your chart for number 3. The city with the largest temperature range is like that because it's landlocked. Whichever city it is, it's landlocked, meaning surrounded by land, and land heats and cools faster than water. So in the summertime, those city locations that are landlocked are going to jump up in temperature very quickly. But then in the wintertime, it's going to cool down very quickly. So it's a much sharper temperature curve because land heats and cools faster than water. That's the main idea for number 6. All right, for number 7, and again, if I'm going too fast, I'm recording this and it'll be uploaded to my YouTube channel so you can go back. And I mean, again, these are like free answers. I want you to do well. And I think by explaining the concepts, it'll help to hopefully make some of this information stick a little bit. So please use the resource. It'll be uploaded to my YouTube page, hopefully actually in the next half hour. So as soon as we're done, I'll try to upload it. So if I'm going too fast, you'll have a chance to go back and listen again. Okay, so for number 7, how do the rates of heating and cooling differ for New York and Bismarck? So rate means speed. So what you'll notice on your graph once you plot it, if you haven't already, is that Bismarck is going to start down by around the 10 °F mark, but then jump up. I'm just looking up to my graph on the side here. That's what I'm looking at. It's going to jump up into the mid-50s by May, and so it's a much steeper slope. So Bismarck is going to heat a lot faster than New York, which has more of a gradual one. It starts off around 33 °F, and in May it's up to 63-ish °F. So it's still a good jump, but the rate of heating is going to be a lot, and cooling is going to be greater for Bismarck. So the rate of heating and cooling is greater for Bismarck. Again, because land heats faster than water. So because New York City is on the Atlantic Ocean, the colder ocean in the summertime makes the land a little bit cooler, but then in the wintertime, the ocean hangs on to the heat a little bit from the summer, and it'll keep the surrounding lands a little bit warmer. All right, so Bismarck has a faster rate of heating and cooling because it's landlocked. Okay, number 8 is a really confusing question. A lot of students get stuck on this one for 8 and 9. So since Los Angeles and Phoenix are at the same latitude, what can you infer or assume about the intensity of insolation at both locations? So intensity means strength of sunlight. So we only have one sun, but the sun is going to strike the surface in different ways because we're a sphere and because we have a tilt. So the intensity of insolation, how strong it is based on how high the sun is in the sky. The higher the sun is in the sky at a specific location, the warmer the temperatures will be. How long the sun is out for. So duration of insolation is the amount of daylight. So like right now we're moving towards summer, so daylight's getting longer. So that's going to make it warmer. So angle, duration, and there's one other one. But the idea is that if you're at the same latitude, remember lat is flat, the intensity of insolation will be the same. Okay, so it's sort of a trick question in a way, like it sort of sets it up like there's going to be a difference, but there's not. So since Los Angeles and Phoenix are at the same latitude, lat is flat, you can infer that the intensity of insolation at both locations will be the same. Because if you're at the same latitude, you're going to have the same hours of daylight and the same angle of sunlight. So it's going to keep the intensity the same. So what you're getting from the sun at those latitudes are going to be the same. So for number 9, you'll notice in your graph that like Los Angeles and Phoenix have very different climates. So the reason why is even though they're getting the same intensity of insolation, Los Angeles is coastal and Phoenix is landlocked. So Because Los Angeles is coastal, it's going to have cooler summers and warmer winters, so it's going to make the extremes less extreme. And Phoenix is landlocked, and it's like in a desert area, right, which sees very extreme because there's not a lot of humidity, so the heat comes in quick, but it goes out quick. So because Phoenix is landlocked, it's going to get much hotter in the summer and then much colder in the winter. It's going to be a much steeper curve. So even though they're at the same latitude and get the same intensity of insolation, you're going to have different temperature curves because Los Angeles is coastal and Phoenix is landlocked. Right. So again, the water basically like evens out your temperatures and makes it less extreme. All right, last couple of questions here. Do you think the unknown city is coastal or continental? So if you look at the numbers for the unknown city, there's not a whole lot of change, right? The coldest temperature is 79, which sounds pretty awesome if you're a warm weather person. And the warmest temperature is 86. So that 7 degrees difference is not much. So because there's not a lot of extremes, like there's not a big change between the coldest and the warmest months, then you can assume that it's a coastal location, right? Because the temperature range is small. So if you're coastal, your temperature range is going to be smaller than if you're landlocked, then your temperature range is going to be bigger. Okay, so we'll end up with a conclusion, and that will cover everything on the lab that you need to do. Just make sure your graph is done. Make sure your graph is a line graph, not a bar graph, so that you can see the relationships between the variables, whether you do it by hand or by Excel. Answering complete sentences, but you don't need to just rewrite the question in your answer. You don't have to write it all out if you're doing it by hand. And again, you have until the 30th to turn it in. So I'll finish up with a conclusion here. And if you have any questions, feel free to stay on. I'm happy to answer those for you. All right, so let's get to the conclusion. So describe the difference in the annual temperature ranges between a coastal region and an inland region. Use data from the lab to support your explanation. Okay, so the annual temperature range for a coastal region is less than the temperature range for an inland region, inland being landlocked. For example, if you look at the temperature ranges for New York, and Bismarck, North Dakota, you'll notice that the temperature range is much smaller for New York and much greater for Bismarck. Something along those lines is fine. So the key idea with the conclusion is that coastal regions are going to have a smaller annual temperature range than an inland region. And then just take a couple of cities and use it as an example. So you can do New York and Bismarck, LA and Phoenix. I think even, yeah, those are probably the best ones. I mean, Alice Springs and unknown, you could probably pair those up too. But I think, either New York, Bismarck, LA, Phoenix are your best bet as an example. So for example, the annual temperature range for New York is this many degrees Fahrenheit, while the annual temperature range for Bismarck is this many degrees Fahrenheit. So that's a good way of taking your data and tying it into your conclusion. Then you can just take it right out of the data chart and use it there. Something to note too is that New York and Bismarck are at the same latitude, so they would also be getting the same intensity of insolation. It's that New York is coastal, New York, like the city is coastal, and Bismarck is inland. So that's why you have the extremes. Okay, so I think that covers everything that you need to do for your lab.